right, welcome to our very first asynchronous video and lesson. Today we are going to talk about the 6 trig functions. Now, if you're following, you might remember that there are 3 trig functions, right? You kind of are remembering your SOHCAHTOA, sine, cosine, tangent, but there are in fact 3 additional trig functions you may or may not be familiar with as well. And warning, I am not talking about inverse functions. So I'm not just talking about sine inverse or something like that. To remind us of our first 3 though, we know that we've got a right triangle, right? So here's our right triangle, and that this is the Greek theta. And of course, maybe you remember, right, it has an opposite side, an adjacent side, hypotenuse. Pretty straightforward. And from our memory for sine, cosine, and tangent, or SOHCAHTOA, we know we can talk about sine of the angle, and we can talk about cosine of the angle, and we can talk about tangent of the angle. And just for calling it out, right, obviously we're in the low budget version here. I'm in my apartment filming on my phone with a portable whiteboard, so we're gonna do what we can. But the sine of the angle, again, SOHCAHTOA, sine is defined as the opposite over the hypotenuse, or it's the relationship between the opposite and the hypotenuse. So I have opposite for sine and hypotenuse. Moving on down the line, again, like you might remember, that means then cosine is defined as the adjacent over the hypotenuse. So I can write it as adjacent and hypotenuse. And our last relationship, tangent, right, defined as opposite over adjacent. So I've got opposite and I've got adjacent. Hopefully those are ringing a bell. Okay. As far as the 3 new functions go, each of these relationships also has a reciprocal relationship. Right? Reciprocal, or my favorite coined term, refliprical, because it's the flip of this fraction. For sine, its reciprocal would be the relationship between hypotenuse and opposite. And that has a name. The reciprocal of sine is called cosecant. And the cosecant is abbreviated as CSC. Here, that means the cosecant of theta is going to be defined as hypotenuse over opposite. Pretty straightforward. Moving along down the line then, of course, the reciprocal of cosine is called secant, and secant is abbreviated as SEC. And you might think to yourself, it doesn't make sense. Why does cosine not go with cosecant? And I would agree with you. That seems a little counterintuitive. It's probably related to the Greek or Latin or whatever. For our purposes, we just got to kind of know that sine and cosecant go together, cosine and secant go together. And secant, like I said, is the reciprocal of cosine, making secant the relationship of hypotenuse to adjacent. Fair enough. Then our last relationship, the reciprocal of tangent, is called cotangent, and it's abbreviated as COT. And of course, following our pattern, that means the cotangent as the reciprocal is going to be the adjacent side divided by the opposite side. These are the 6 main trig functions. I would highly recommend, if you don't have them written down, that you hit pause and write it down. We're going to move on to an example next. All right, so how would we use these 6 relationships? You might have a problem that says, hey, find all 6 trig relationships for that triangle. Well, this first 3 are something you may have done back in your geometry days. To find the sine of an angle, I need to know the opposite side and the hypotenuse. Now, hopefully right off the bat you're recognizing like, wait a minute, I don't know the hypotenuse. So let's pretend this video was overwhelming, or you're rusty, you're getting used to it, and you don't recognize that this is a 3, 4, 5 right triangle. To find the hypotenuse, or to find any side that was missing, I could, of course, real quick, do a little Pythagorean theorem. Right, so I would have 3 squared plus 4 squared equals c squared, my hypotenuse. I know that 3 squared is 9, 4 squared is 16, c squared, I don't know, 9 and 16 is 25, and I would get that my hypotenuse is, of course, 5. You're always welcome to use the Pythagorean theorem or to recognize your perfect triples, or Pythagorean triples. So now that I know all 3 sides of a right triangle, I can go ahead and use what we previously talked about these relationships, right? I know the sine of theta is opposite over hypotenuse, meaning whatever theta was here, the sine of it would be 3 over 5. Pretty simple stuff. And once I know sine, of course I automatically know cosecant, because cosecant is the reciprocal of sine. So if sine is 3 over 5, cosecant is 5 over 3. Oh, fun surprise. Moving along anyway, if cosine is adjacent over hypotenuse, the adjacent side here is 4. So cosine would be 4 over 5. And again, if I know cosine is 4 over 5, then I know secant, because it's the reciprocal of cosine. Secant would be 5 over 4. And again, lastly, tangent, opposite over adjacent, is 3 over 4. So if we know tangent, we then know cotangent, because it's the reciprocal. Cotangent would be 4 over 3. That's it. And now I have found all 6 trig relationships for that right triangle. So next up is your homework assignment. Alrighty, so here it is, your asynchronous assignment for the week, embedded in the video. Maybe tricky, maybe cruel, we'll find out. Straightforward. For your asynchronous assignment, all I want you to do is find all 6 trig ratios for this right triangle. You'll submit it right under this video. Thanks, good luck. Let me know if you have any questions.